For this video, I'm going to show how to calculate the square root of an 8-digit number using a method that is far simpler than the long division method that is shown in many classrooms. Instead of showing how it works first, I'm going to show that it works, and then I'll use the algebra to show why it works. So to start, we're going to start with a number. The number I'm going to use is 202625441. The first thing we need to do, clean this up a little bit, is pair off the digits. So we see that the answer is going to have 4 digits. And in order to find the first digit, we take the first pair and find the square root of that number, which is going to be 4, because 4 times 4 is 16, but 5 times 5 is 25, which is too big. So we're going to use a 4 as our first digit. Since we know it's going to be a 4-digit number, we know the range is going to be 4,000 to 5,000. So here's how the method works. We're going to start with the number 202625441. We're going to divide that by a number. But before we do that, we're going to divide by another number. The first thing we're going to do is write down our digit, 4. We know it's a 4-digit number, so it goes over this digit. We're also going to write that number here. Then we take this digit, multiply by 2, and add 1 and write it here. So this becomes a 9. The next thing we do is take that digit, multiply it by 1 plus that digit. 4 times 5 is 20, and add it to that original number. So 20 plus 20 is 40, and we bring down the next 3 digits. And then we do the division. So 9 times 4 is 36. It has a remainder of 4. 9 times 4 is 36. It has a remainder of 6. 9 times 7 is 63 with a remainder of 3. And then 9 times 3 is 27. So that's the first number we're going to start with. We're going to take that and divide it in here, but we're also going to extend it 1 decimal place. So we'll put a .0 at the end. Now we don't need the 20 under here anymore, so I'll erase that. And now, to make the division simpler, and this will come in handy when we proceed down this method, I'm going to take this 4473, I'm going to double it, double it, double it, and then halve it and multiply by 10. What I'm doing is I'm creating 2 times, 4 times, and 8 times the number, as well as 5 times the number. 5 is 10 divided by 2. So I'm going to be doubling this number, which becomes 8946. I'm going to double it again, which becomes 17892. And I double it again, which becomes 35784. Then I'm going to take this number and halve the number, and then extend it by 1 digit. So that becomes 2236.5, and then you multiply by 10 and you ignore the decimal point. So this is going to allow us to do this division simpler. We know the first digit is a 4, so this is 2, 4, and 8, and then this is 5. This is a better 5. So we're going to put this 4 here. 17892. Okay, so that becomes 0732. And then we bring down the 5. And the next thing we notice is that the closest number that is less than this one is 5. Because if we try to add 2 and 4 together, we're going to get 25 as our first two digits, and that's too big. So we want a 5 here. So the next digit is a 5. So we write 2, 2, 3, 6, 5 here, and subtract those, and we get 0, 4, 3, 1. And then bring down the 4. And for the next one, we see that 2 is a lot smaller, so maybe we want 3 here. So this is 8 plus 4 is 12, 9 plus 4 is 13, which makes this 13, 1, 3, 3, and then this adds 11, so this becomes 1, 3, 4, 1. That's too big. Barely, but it's too big. So we do want a 2 here. A 3 will not work. So I'm going to put a 2. 8, 9, 4, 6. Subtract that, and we get 4, 4, 5, 8, which is smaller than that, so we did it right. Then we bring down the 1, and we see that even 8 is too small, and 35 plus 4 is 39, which is still too small. So this is a 9. And when we add those together, we get, let's add 8 and 1. So that's 3, 9, that's 4, 0, 2, 5, 7. Subtract that, and we get 4, 2, 3, 4, which is still less than that, so we're good. And we bring down a 0. Well, we know that this is 9, and that's smaller than this, so this has to be a 9. And we don't need to do the math any further. So now we have this number and this number. The next thing we want to do is add these two numbers together. So I will do that, and the number I get is 9002.9, but I'm going to ignore the decimal point. The next thing we want to do is divide into our original number, 20262541. But since we moved this decimal point out of the way, we need to put a 0 on the end of this. And because we want to go to 4 decimal places, we'll add 4 zeros on the end. Now, similar to what we did before, we're going to do 2, 4, 8, and 5 to this number. So if we double this, we get 180058. Double that again, 360116. Double it again, 720232. And then we take half this number, we get 450 0.45, but we're ignoring the decimal point in this case. Now, are we getting close to the answer? Well, if you look at this number, and this number, they are getting very close to each other. This one and this one are about 50 apart, and 50 or so, and this one is halfway in between these two because we added them together and divided by 2. This is much closer to the answer. In fact, what's going to happen is we'll discover that these first 4 digits are the right answer. So when we divide this out again, what I'm going to want to do is put a decimal point here and a decimal point here because we're going to add 2 numbers together. The 2 numbers that we're going to add together is half of this, which is 2250.725. Divide that by 2, and that's what that is. Now, if this is correct, which it will be in almost all cases, then this number divided into this is going to be 2250 point something. So let's multiply out 90029 times 2250. How do we do that? Well, this is going to make the division a lot faster. We're going to take 2, which is here, 180058. We're going to take 2 again and move it over 1, 180058. Then we're going to take 5, which is this one, and put it here, 0, 1, 4, 5. And then 0 is the last digit, so we're going to tack on another 0 there. And then we add these up. And the number we're going to get is 0, 5, 2, 10, 15, 6, 5, 2, 2, 0. Notice this is very close to this number. So that's 2250. Now, if that's not the right answer, it's going to be close. So let's find out if it is the right answer. 65250. We subtract these two numbers, and we're going to get 0, 6, 1, 0, 6, 0, 0, 0, 0. Okay, and that number is less than this. So that is the right number to use, so we can put 2250 right there. We've just done half the division. We bring down the 0, and we look to see which one of these is correct. Which one of these is closest to this? Well, it's greater than 5. It's less than 8. Is it a 6, maybe? This is going to be 540174, which is less than this. So that's going to be a 6. So we're going to add these up. This is going to be 3 plus 1 is 4, but there's a carry there, which makes it a 5. Then that's a 4. That's a 0. That's a 1. That's a 6, but there's a carry there, so that's a 7, 4. And that is the number we want to subtract. And the number we get is that. And then we bring down the number again, the 0. Now that's really close to this, so I'm pretty sure that's going to be a 6 again. So 540174, and this time the answer we're going to get is 68047. Okay. Then bring down the 0. Now that's bigger. Now that's bigger than 6. It's actually bigger than 8. But it won't be bigger than 9. It won't be 9 because 72 plus 9 is 81, and that's too big. So this is going to be an 8. So put an 8 here. And then write the 8 here, 720232, and subtract 82602 and carry down the last 0. Now that number is really close to a 2. So since this is the last digit we're going to calculate, I'm just going to put a 2 here and then stop. Now, the final thing we're going to do is add these two numbers together. And I'm going to do it backwards because I don't have any room underneath. The final step to this method is to add those together. And you're going to get 4501.3932. And that is the correct answer for the square root of this number. Now you notice here we had the integer correct, 4501.45. Very close to this number here. And that's also kind of close here. We had 2 digits right here. We had 4 digits right here. and over here we have 8 digits right. And that is the method that I use to calculate an 8-digit square root. What makes this a lot simpler is I use these numbers to help me figure out what numbers go here. And over here, I do a pre-multiplication knowing that this number is very close to the right answer. So I multiply it out, I get this, and that is half the division for the one that's really complicated. That makes this division a lot simpler, that plus this. So this method is accurate to 8 digits, 4 decimal places, and in many cases, if we were to continue this out, we would get a couple of more digits here before the answer is wrong. Now, the only way we know the answer is wrong is if we double check it with a calculator, but using this and stopping at 4 digits, we know that in every case, unless we did some of the math wrong, that this is the correct answer to 4 decimal places. Also, notice that since these numbers are similar as we go down this procedure, and we keep using some of the same numbers over again, if you make a mistake along the way, you're going to notice that, let's say this came out to be 4521.45. Well, that's not halfway between this, so that's wrong. Is it wrong because you didn't add this right? Is this number wrong? Or did you divide this wrong? It alerts you that there's a problem, and these two numbers will tell you there might be a problem. This number not agreeing with these two might tell you there's a problem. If these two numbers are very different, then you've done something wrong in here. There are a lot of places where if you pay attention, you will be able to tell when you've made a mistake somewhere in this math, and you'll be able to go back and correct it. So this method is also self-correcting, or at least self-alerting that there's a problem. If you don't make any mistakes, then these 4 numbers here will be almost in agreement. And that is how this method works.